Welcome everybody, Math 104. This is section 1.5, linear inequalities in one variable. Take a look at the introduction. College student is shopping for a cell phone plan. Plan A costs $22.50 per month and you have to buy a phone for $99. Plan B, you get a free phone, but it costs $34.75 per month. Clearly, Plan B is the better deal initially, because you only have to pay $34.75 up front, whereas with Plan A, you've got to pay $121.50. But we want to know, after how many months would Plan A be the better deal? So these are the types of questions we'll be able to answer by the end of this lesson. Like a lot of questions in math and science, the answers are ranges of numbers. So we're going to need some special notation to express these answers. So let's say we've got a range of numbers between 3 and 9, and that's going to be a solution to some problem. So we need to be able to express this both graphically and in symbols. So if we graph a single number on the number line, we just graph it with a dot. But if we graph ranges of numbers, we're going to shade in everywhere inside the solution set. So let's say we want to graph all the numbers between 3 and 9. So we put parentheses on 3 and 9 and then shade in the middle. So this graph represents all numbers between 3 and 9. That includes all the decimals. So 5.4, 6.238, those are all in there. Every possible decimal between 3 and 9. So this begs the question, are the endpoints included in the solution set? Well, it depends on the symbols we use. In this case, we have parentheses. So that corresponds with this inequality. 3 is less than x is less than 9. In this case, the endpoints are not included. So this would be every number between 3 and 9, but not including the values 3 and 9. Now if we wanted to include 3 and 9, we have to use different symbols. So less than corresponds with parentheses. So where you see less than or greater than, strictly less than or greater than, use parentheses. Now here we've got less than or equal to. This corresponds with a bracket. So if you want to graph this, we're going to use bracket on 3 and a bracket on 9 facing inward. And that means every number between 3 and 9, including 3 and 9. So if you want to include the endpoints, use brackets, and the brackets correspond with less than or equal to or greater than or equal to. If you do not want to include the endpoints, use parentheses, and the parentheses correspond with less than or greater than. So your turn number 1. Like everybody to graph this inequality. -7 is less than or equal to x is less than or equal to 4. And when you graph this, make sure you make it look like the example where you put the graph right on the number line. All right, it should look something like this. So we're going to start at -7. We have less than or equal to, so that's a bracket. And when I graph this one, I'm actually going to write it below because I don't want to have to keep erasing the number line and redrawing it. But when you graph it, make sure you put it right on the number line. So at -7, got a bracket because it's less than or equal to. And the other endpoint is 4, so another bracket there. And then we shade in between. So just darken it up real well so you can see exactly where it's shaded and where it's not. Now to express solution sets that consist of ranges of numbers, we're going to use what's known as interval notation. So here's some examples of interval notation and how they correspond with things I'm sure you've seen before, which are inequalities like this. So these mean exactly the same thing. This means every number between -3 and 5, including the endpoints. And here, since we have brackets, this also means every number between -3 and 5, including the endpoints. So again, where you see less than or equal to, use bracket. Now here, we've got every number between -3 and 5, not including the endpoints. So here we'll use parentheses, -3 to 5. So interval notation contains all the information that these inequalities contain. It's just a little more compact way of writing it. Think of it as being a shorthand. Interval notation is shorthand for these inequalities. Now, you don't have to have the same symbol. You could have less than or equal to and less than. You can mix them up. In which case, we're going to have different symbols here. We've got -3 is less than or equal to, so that's the bracket. And on this side, we have strictly less than, so parenthesis there. And in this case, we got the reverse. We got strictly less than here, so that's the parenthesis, less than or equal to, bracket. We could also have infinite intervals. So these intervals have an endpoint on both sides. But these intervals only have an endpoint on one side. And in the other direction, they go on forever, all the way to infinity. So consider the inequality x is greater than or equal to 5. So that could be any number greater than or equal to 5. It could be 5, 6, 7, 8, 10, a billion, trillion, just goes on forever, all the way to infinity. So that's why we're going to use the infinity symbol in the interval notation. So we've got greater than or equal to 5, so we're going to have 5 be on the left-hand side with a bracket. Now notice that in all of these, the larger number is always to the right. That's always how interval notation is used. The larger number has to be to the right. Now infinity is it represents the largest number you can possibly imagine, so that's going to be on the right. So we go from 5 to infinity. That's every number greater than 5. If we want to do less than 5, means our endpoint is on the right-hand side. We want every number less than that. So that's to the left on the number line, and we can go all the way to negative infinity to the left. Now notice whenever we have an infinity symbol, it doesn't matter if we have greater than equal to or greater than, the infinity symbol always has a parenthesis. And the reason is, if we're going to use a bracket, then that number has to be in the set. So for this one, 5 is in the set. But here, if we were to use a bracket here, what that says is infinity is in the set. But infinity isn't an actual number. Infinity is just kind of an idea. It's the idea that a number can get as big as we want. So infinity is not really in the set. So that's why we have to use a parenthesis there. Now here we've got strictly greater than 5. So next to the 5, we have a parenthesis. Here we have strictly less than 5. So we have a parenthesis. We're less than, so we're going all the way to the left. All right, so make sure that you can use interval notation to express ranges of numbers. So let's practice that. Your turn number 2. We're going to write these inequalities in interval notation. First one, x is less than -2. So we have strictly less than, so that is going to be a parenthesis next to -2. And we're going all the way to the left, so we're going all the way to negative infinity. So negative infinity to -2. Next up, we got -3 is less than or equal to x, less than or equal to 1. So we have two endpoints here, so not an infinite interval. This will be a finite interval with endpoints at -3 and 1. We have less than or equal to, so that's the bracket, less than or equal to, bracket. All right, x is greater than or equal to 9. So it's greater than or equal to, so we use the bracket next to the 9. And we're going all the way to the right because it's greater than. So 9 to infinity. And next up, we got a mixed one here. We got 4 less than or equal to, so that's a bracket. 8, and then a strictly less than, so that is a parenthesis. Next type of notation is set builder notation. And to do an inequality in set builder notation is actually quite a bit easier than interval notation, because really all we have to do is take the inequality and stick it into the notation. So let's say we want to write -8 less than or equal to 4, or x less than 4. And we're going to write this in set builder notation. So set builder begins with always a bracket. Now, whatever variable we have in here, we have to announce that at the beginning. We're going to have an equation or some expression over here with x's. All right, next up is the vertical line. This means such that. So this means all x's such that. So you can think of that as being all real numbers such that, and then we're going to list the requirements over here. So then you take the inequality and put it here. Just write it exactly as written. -8 less than or equal to x less than 4, and closing curly brace. And that's set builder notation. So just take your inequality and stick it in there. It's going to be in this format every time. It always starts with the curly brace, variable, vertical line, inequality, closing brace. Your turn, number 3. Write x greater than 12 in set builder notation. All right, so we got our curly brace, our variable, vertical line, x greater than 12, close the brace. So a lot of math is just getting used to notation, so make sure you're just familiar with all these different ways of writing intervals. All right, so why do we need these intervals? Because these are going to be our solution sets. Solution sets when we solve inequalities. So that's what we're going to do next. Solving linear inequalities. Now when we solve inequalities, we're going to use basically the same properties as when we're solving equations, but with some important differences. The main difference is when we are multiplying by negative numbers. So let's say c is a negative number. C is less than 0. Then if a is less than b, and c is a negative number, that means AC is greater than AB. So if we multiply both sides of this inequality by C, we get AC is greater than AB. Now notice what's happened here. We started with A is less than B, and then we switched the direction on the inequality. So when solving inequalities, if you end up having to multiply or divide, works the same way, each side of the inequality by a negative number, you have to flip the direction of the inequality symbol. All right, let's see why that's the case. Let's say we're starting off with -2 is less than 4. So that's a true statement. Now we need C to be less than 0, so let's say C is -3. Now I'm going to multiply both sides of this by -3. All right, -2 times -3 is +6. 4 times -3 is -12. Now if we don't reverse the inequality, we get this statement, 6 is less than -12. Clearly that is not true. So we have to, since we multiplied by a negative number, we have to switch the direction of the inequality, and now it becomes true. 6 is greater than negative 12. All right, so we're going to solve the inequality. Negative 8x is less than 56. And we solve these, we're going to express the answer in interval notation. Coefficient is negative, so we're going to divide both sides by negative. Remember, this property works with both multiplication and division. So that means we're going to have to switch the direction on the inequality symbol. That means x is greater than negative 7. All right, now we are going to express the answer in interval notation. So it's greater than negative 7. So we get negative 7 to infinity. And then if we want to graph this solution set, and when you graph these, just put a couple numbers on the graph. You don't have to fill out a whole bunch of numbers. It's kind of a waste of time. We definitely want the endpoints. So negative 7, maybe one more, maybe one on either side, something like that. And that's fine. Okay, now we're going to use the same symbol in the graph. We got a parenthesis here, so we're going to use a parenthesis there. And fill in all the way to the right. And when we're graphing all the way to infinity, fill in the arrow, because a filled in arrow indicates we're going infinitely to the right. Your turn, number 4. Solve the inequalities, graph the solution set, and write the answer in both set builder and interval notation. So we're going to solve this inequality. We're going to solve it just like we would an equation, but keep in mind our one difference that we just saw with the multiplication property. So start by simplifying both sides. We're going to clear the parentheses with distribution. All right, so there's the result of distribution. Now we're going to combine like terms. 6x and 3x, it's 9x. All right, now I'm going to get all the x's on the left-hand side, add 4x to both sides, and then add 6 to both sides. That gives us 13x. It's greater than or equal to 0. Divided by 13, we're dividing by positive numbers, so we keep this in the same direction. So x is greater than or equal to 0. All right, now, so there's our answer as an inequality. All right, there's set builder. Stick the inequality inside the brackets. And then for greater than or equal to 0, we're going to have a bracket because it's greater than or equal to. And we're going all the way to the right, so 0 to infinity with a parenthesis on infinity. Part B. So for this one, we've got some fractions in there. I'd like to get rid of those. So I'm going to multiply the entire equation by 4, because the least common multiple of the denominators is 4. All right, so the 4's cancel here. So that leaves us just with x plus 3 and plus 2 greater than. Here, the 4's cancel, leaving the 3. So we have 3 times x plus 8. Now let's combine like terms and distribute on the right. Let me get all the x's to the right, all the numbers to the left. And over here we got negative 19. I'll divide both sides by 2. We're dividing by a positive number, so we keep this in the same direction, keep the symbol pointing in the same direction. I think I got a, oh, I made a mistake. When I distributed, forgot to multiply by this 2. That should be an 8. All right, when you distribute, you have to multiply by every term. Here's a term, here's 1, and here's 1. So I missed that one, so that's an 8. All right, so here we have x plus 11 instead. So we get negative 13 halves is greater than x, or x is less than negative 13 halves. So since it's less than, interval notation, we got negative infinity to the left. We got strictly less than, so negative 13 halves goes here with a parenthesis. And then set builder. When you write it in set builder, generally you're going to put the variable to the left, so I just flip that around. And the graph then, all right, we got negative 13 halves here, I have a 0 over here somewhere. And now it's strictly less than, so this could be a parenthesis, and it's all the way to the left. So fill in the arrow there, and there's your graph. So what we've seen now is two-part inequalities. We got one expression to the left, one expression to the right, separated by a single inequality symbol. And notice the answers to those were all these infinite inequalities. That's because we only have one endpoint. But what if we want 2 endpoints? So our answer would be one of those intervals with just numbers in it and no infinity. Well, if we want to get one of those as our answer, then we're going to need a little different type of inequality. We're going to use a 3-part inequality. So that will give us 3 parts separated by 2 inequality symbols. So we have three sections to this inequality. We got this part separated by an inequality symbol. We got the middle part, another inequality symbol, and part 3 over here. Now when we solve these, whatever operation we're going to do, instead of doing it to both sides of the equation, well, we have 3 sides of the equation, so we're going to do it 3 times. So if I want to get x by itself, I need to subtract 7 here, so I'm going to do it here as well and here as well. So 3 operations. -2 minus 7 is -9, less than 3x, less than -6. Now I can divide by 3, all 3 spots here, and that gives us -3, less than x, less than -2. So all numbers between -3 and -2, not including the endpoints. In interval notation, since we have strictly less than, we're going to use a parenthesis. There's interval, and then set builder, x such that -3, less than x, less than -2. And then the graph, -3, -2, parentheses, because we have strictly less than, and fill it in. So we should have the same symbols in interval notation as we do on the graph. That brings us to your turn, number 5. To get x by itself, we're going to have to get rid of that 4, so add 4 to all 3 sides. So we got 9 over here, 3x less than 13. Now divide everything by 3, all 3 sides. So that gives us 3 less than x less than 13/3. All right, interval notation. Strictly less than gives us parentheses. To do set builder, stick that inequality inside the notation. All right, there's set builder and the graph. Let's see, we got 3 here, 13/3, everything in between. Now we're going to look at a couple of application problems. Generally, they're going to involve inequalities. Applications involving inequalities generally involve setting up an expression to represent a quantity and then making a comparison to minimum or maximum values. So for example, a student has scores of 82, 88, and 94 on the first 3 exams in the class. What score does a student need on the 4th exam to average at least 90? So there's our minimum value we want, is 90 for the average. So how do we calculate an average? We add up all the scores and divide by the number of scores. So first 3 exams are 82, 88, and 94. But we don't know the score on the 4th one. Well, I used S on this. Generally, I try to avoid S because it looks like a 5, so I'm just going to use X instead. Alright, so there's our 4 scores on the exams. First 3 we know, last one's an unknown, so that's our variable. And to find the average, we divide by the number of scores, which is 4. Now we want the average then to be at least 90. So greater than or equal to 90. Now we can solve this for x. So if we get rid of this 4, we'll multiply both sides of the equation by 4. That gets rid of the 4 and leaving just the numerator. So we got 82 plus 88 plus 94 plus x equals 90 times 4 is 360. Now we'll add up all these. And that gives us 264. Whoops, not equal, greater than or equal to. Greater than or equal to 360. Solving for x, and we get rid of 264. So x is greater than or equal to 96. So the student needs at least a 96 on the final, or on the last exam to get an A. Your turn, number 6. A student has scores of 89, 98, 91, and 90 on the first 4 exams in the class. What score does the student need on the 5th exam to average at least a 93? So first 4 scores, 89, 98, 91, and 90. We don't know the 5th one, so there's our variable. We have 5 scores. To find the average, we divide by 5. And we want the average to be greater than or equal to 93. All right, now we're going to multiply everything by 5. Get rid of that fraction. This cancels, leaving us with just 89, 98, 91, and 90. Plus x greater than or equal to, we got 93 times 5, that is 465. Now we're going to add up all these. Get 368 plus x is greater than or equal to 465. Subtract 368 from both sides, and we get x greater than or equal to 97. So that student needs to score at least a 97 on the 5th exam to get a 93 for the class. Next example. Got a rental company A charges $5 to rent a leaf blower plus $1.75 per hour. All right, $5 is the initial charge plus 175 per hour, so we take 175 and multiply by the number of hours h. All right, so we're dividing h to be number of hours rented. Now B, company B charges $10 plus $1 per hour. So we got $10 plus 1 times h. After how many hours does renting from company B become the better deal? Because we have to pay less up front to company A, $6.75 to get started here, whereas here we have to pay $11 to get started. But after a while, since we have a lower hourly charge, this one's going to be cheaper. So, after how many hours does renting from company B become the better deal? Better deals are cheaper, cheaper is less, so this side needs to be less. So we want to know when company B is less than company A. Now we can solve for h. So we're going to bring all the h's over here, all the numbers to the right. So this will be 0.75h greater than or equal to 5. Divided by 0.75 on both sides. and H is greater than or equal to 6.7 hours. So company A is cheaper if you rent for less than 6.7 hours, and they're equal if you rent for exactly 6.7 hours. And actually, we want to know when it's the better deal, so I should not have put an equal sign there, because it's an equal deal if they're equal. We want it to be cheaper, so should have only put greater than there. So if H is greater than 6.7 hours, then company B is the better deal. And that brings us to your turn, number 7. This is the introduction about the cell phone plans. So plan A, $22.50 per month and $99 phone. So 99 plus 22.5, and I'm talking about months, so I'm going to use M. All right, so there's the cost. Plan A. Plan B is a free phone and $34.75 per month. So B is cheaper up front. We want to know when A is going to be cheaper. So plan A is cheaper than, less than, 34.75 M. Now we are going to solve for M. Subtract 22.5 M from each side. That gives us 99. It's less than 12.25. Now we'll divide, or 12.25 M. Now we'll divide by 12.25. And we get 8.08. So M has to be greater than 8.08, so a little over 8 months into it. That makes plan A the better deal. All right, everybody, that's it for today. Have a great day.